In this video, we're going to be talking about algorithms. This will enhance our understanding of the Ask Data model and also prepare us for the various activities we'll be taking on all semester long as we create custom software. In Computer Science 110, normally the analysis and specification steps for a software project will already have been conducted for you. And the results of those will be given to you as a problem assignment. So in other words, normally you won't be working for an actual client. You won't need to meet with them to discover what kind of needs they have for their software. And you won't need to document them so that you all can get on the same page. Instead, your instructor will have carried out the analyze and specify steps for you and will provide those for you in the form of a problem assignment. So normally we'll be starting the process in the design step, the third step in the Ask Data model. Now, when computer science create their plan for solving a problem, they use a fancy word to describe that plan. That fancy word is algorithm. An algorithm is a repeatable sequence of steps for solving a problem where the steps have to have a termination point. In other words, there has to be a point in time where you can point to the solution and say, that problem has been solved. So remember, algorithm, it's a repeatable sequence of steps for solving a problem, and the steps have to actually end in the solution. Now, in order for you to get some experience in writing an algorithm, we're going to perform a class activity, making a peanut butter and jelly sandwich. Making a peanut butter and jelly sandwich seems like a simple task. We want to know, what is, in your opinion, the best peanut butter sandwich in the world, and how do you make that peanut butter sandwich? So take a moment and pause the video and write down your instructions for creating the perfect peanut butter and jelly sandwich. Do you have the steps? Well, let's think about your steps. If we were live in class, we would collect everybody's sequence of steps, and I would bring out physical peanut butter and jelly so that we could carry out some of the algorithms to test them out. Now, when I'm making peanut butter and jelly, I do not like white bread. So I would not bring white bread to the table to make the ultimate peanut butter and jelly. And I like raspberry jelly, not strawberry or grape. So that is an ingredient that I would bring to the table. And if we were live in class, I would bring soy nut butter instead of peanut butter, just in case anybody was allergic. Now, you might not have written your algorithm using those ingredients. You might have assumed there was different things available. So you might need to modify your algorithm based on this new information. You might also want to know what kind of tools I have for making the peanut butter sandwich. I would provide a plate, one knife, and one spoon. So again, take a moment, pause the video if you need to, recreate your algorithm using this new updated information that you got. You have one plate, one knife, one spoon, soy nut butter, raspberry jelly, and wheat bread. Fantastic. So most people have a pretty, have some past experience with peanut butter and jelly. And so when you're writing your solution, you might make some assumptions about how somebody would carry out the instructions, assuming that they also have experience making peanut butter and jelly sandwiches. But you might be trying to convey your algorithm to somebody who's never experienced peanut butter and jelly before. And so they might not have that same shared experience that you're assuming. So for example, you might have said things like, take some bread out of the bag. And that's great, but what if my bread isn't in a bag? Or what if I don't know the protocol for opening a bag, and instead of untwisting the end and opening it gently, I just tear the bag open in the middle and the bread goes flying all over the room. Or suppose that you say I should take the peanut butter and rub it on one side of the bread. we would know that that meant to open the jar of peanut butter and use the knife to remove some, and then use the part that's on the knife to spread it on the bread to make your sandwich. But again, somebody who's never experienced that before might not make the same assumption. So one of the key things we can learn from this peanut butter and jelly example is that it's important to know what tools you're using, and it's also important to know what kind of assumptions you can make, and to communicate things in the most clear way possible. Take a couple seconds, pause the video, and see if there's a few things in your own algorithm that you could like interpret in a funny or different way if you were like an alien from another planet and had never experienced peanut butter and jelly. So hopefully you were able to find a few things in your own algorithm that were funny. I'm going to link another video about making peanut butter and jelly so you can watch that and experience that later. In the meantime, think for a minute about how you would define the term algorithm in your own words. Remember, there was like 3 key ideas about it. See if you can get those all in there in your own words without looking at the top of the page. Once you've done that, think about some issues that are critical for successfully writing an algorithm. Pause the video and take a moment to write those down. Typically, some steps that people are able to identify as critical for success in writing an algorithm are that you need to be really, really clear. You have to make sure that your steps are granular, that they're small, that the person or thing carrying out the instructions understands what you're talking about, that you're using the same kind of shared language, shared assumptions, and that you know what kind of tools are available to you. Those 3 things are pretty key in having success in writing an algorithm or a plan for solving a problem. And no surprise, those are essential when you're communicating with a computer as well. Computers are not smart. They're just hunks of metal with some electronics inside. And so the computer doesn't have a lot of context or shared experience with you. It has a limited language, so you have to make sure you communicate in a way that the computer understands. And the computer has a sequence of tools that you can use to successfully communicate ideas to the computer so that it can carry out those instructions. So being able to carry out those kind of steps when you're planning out an algorithm are going to be really important for success in this course. Thinking back to the algorithm, if you wanted to describe it in your own words, remember it is a sequence of steps to solve a problem. The number of steps in there has to be finite. In other words, it has to have an ending point, someplace where you can say, yes, that is the solution.